Students, welcome to isometric projection. In this class we are going to draw isometric projection of solids. The first problem is a rectangular block 60 by 40 60 by 40 by 20, 60 by 40 by 20, just like a matchbox. 60 by 40 by 20 rests on the ground. This is the plan and elevation of the block. 60, 60, 40, rectangle, height 20. A rectangular block 60, 40, 20 lies on the ground. We have to draw its isoview. Okay. Now, what is its plan? Its plan is a rectangle. Assume it is a piece of paper, rectangular piece of paper, a rectangle seen in plan. What will you do? You draw the two axes, 30-degree axis. Draw the 30-degree axis. Take the distance AB and mark here AB. Take the distance AD and mark here AD. What is? This is 60, this is 40. Draw parallel lines. What do you get? You get C. You get C. After getting C, consider the height of the block. How much is it tall? How much tall it is? 20 mm. Draw vertical lines at all the four corners whose height is 20 mm. E, F, G, H. Connect them. Now, make this dotted. This is the isoview of the block ABCD, that is 60 into 40. The block ABCD 60 into 40, height 20. 60, 40, 20. This is the isoview. Agreed? Now, instead of drawing ABCD first and then taking the height 20 mm along all the four vertical corners AB and C, AB, C and D, you can draw AB, F, E first and then go to that direction in the depth if you want. Or you can draw A, D, E, H and then go the depth in that direction also. Though many ways, the three ways can be adopted, but what I have explained is the easiest. Draw the plan, rectangle seen in plan, then take the height up. Very simple, direct question. Now, actually to draw isoview of this block, if the question describe the block, how to describe it? A rectangular block 60 mm by 40 mm by 20 mm thick. Then this is not required. Sometimes in the examination or in the question, draw isoview of the figure of the solid given in the figure. In such a case, this will be given. Draw isoview of the block given in figure, then the figure will be given. Otherwise, what they will say? Draw isoview of a block 60 by 40 by 20 mm thick. Then you have to visualize the object. When the question is described, it is not necessary that you draw plan and elevation. Plan and elevation actually do not carry any mark in isometric projection. Agreed? But many people believe that plan and elevation will carry mark. No, it cannot carry mark. But there are problems where either plan or elevation or both are necessary to draw this. So, if plan or elevation or both are necessary to draw the isometric view, this will carry mark. Agreed? Especially when there is a cutting plane or especially when the object is tilted and lying in an odd position. In such cases, or when an object is sitting on another object with some gap, a difference in gaps on the sides, etc. In such cases, you will have to draw plan or elevation or both, and then from that you may have to come to this. Otherwise, when the object is well defined, there is no need of plan and elevation. So it's a simple waste of time if you draw plan and elevation while drawing isometric view. I hope you understand. Okay, in the next question, we will draw isometric view of a hexagonal prism. Let us consider a hexagonal prism, say 25 mm side, 60 mm axis, standing on its base on HP. What is the plan of a hexagonal prism resting on its base on HP? It's a hexagon. Agreed? It's a hexagon. In this particular problem, when a hexagonal prism is standing on its base on HP like this, or when it is lying on HP on a rectangular face, or a pentagonal prism standing on its base on HP or lying on a rectangular face, in such cases you have to draw plan or elevation depending upon the orientation, and from there only you can come to the isometric view. Okay, if you want to avoid plan and elevation, there are certain methods you may have to make some calculations. So in such cases where the plan and elevation is necessary, it will carry mark. So here a hexagonal prism is standing like this. What is the plan of this prism? The plan of this prism is a rectangle. Plan of the prism is a hexagon. I mark it A, B, C, D, E, F, the corners of the base. F, G, H, I, A, B, C, D, E, F, G, H, I, J, K and L. On the top, axis OP. Now, how will I draw this? Just like the previous problem where the plan is a rectangle and therefore we start from that 30-30 axis. Here the plan is not a rectangle, plan is a hexagon. What you have to do? Inscribe this hexagon in a box. Inscribe this hexagon in a box. Which box? The box named 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8 is a box whose one side is equal to 1, 2, other side is equal to 1, 4, and whose height is equal to the prism height of the prism. I inscribe the hexagonal prism in this box. Now forget the hexagonal prism, think of the box and draw isoview of the box. This box is same as or similar to the previous problem, the previous box, rectangular box 60, 40, 20. Here the dimensions are not known. This is one side, this is the other side. Height is equal to the axis side of the prism. The prism is 25 mm side and 60 mm tall. Hexagonal prism. So what I do is, I draw the two axes. One, I take the distance 1, 2 and mark here. 2, 1, 4, parallel lines, 3, 4. You can see that 1, 2 is more than 1, 4. So this 1, 2 is more than this 1, 4. Therefore, this will not be a rhombus, it will be a parallelogram. Now, from all these four corners, take the height of the prism up. Height of the prism is equal to axis height 60. Since this is not a rhombus, a vertical line through 1 will not pass through 3. It's a check. If it's a rhombus, vertical line through 1 will pass through 3. Since it's a parallelogram, vertical line through 1 will not pass through 3. Okay. Take the height up. Vertical line at 2, vertical line at 3, vertical line at 4 and complete. Complete what? Complete the parallelogram. 5, 6, 7, 8. Very light. This is drawn very light because such a box doesn't exist. What exists is the hexagonal prism. Now on this you have to locate the points of the hexagon. On the way from 1 to 2, there is a point called DA. On the way from 1 to 2, there is a point called DA. Take the distance and mark here. It's the same as this, same as this, same as this. So if you take this distance, how many places you will mark? You will mark it at 8 places. 1, A, 2, 3, 4, 5, 6, 7, 8. Agreed? On the way from 2 to 3, there is a point going to C, same as this. If you take this, how many places you will mark? 4 places. 2 at the base. Now, listen. Please listen. When an object is here, this is a very rude explanation. I will come to correct explanation later. This is the box which you have drawn in the first case, 60, 40, 20. For the time being, assume that view is elevation, this view is plan. You know that isometric view is a view from a corner at a height. Agreed? I repeat. The view from there is equal to front view or elevation. The view from the top is equal to top view or plan. Assume for the time being that isometric view is a view from a corner at a height. From the corner of your room. That view is called what? Isometric view. That is what we are drawing now. For the time being, assume it like that. Actually, it is wrong. I will come to the correct explanation later. Agreed? So that is how you draw. Now, when this prism is standing, what do you do? View from there is called elevation. View from top is called the plan. What is iso view? Iso view is a view from a corner at a height. For the time being, assume it like that. Will you see the top surface? Yes, the top surface will be visible. So the top is firm. Agreed? This will be visible. Firm. This will be visible. This will be visible. This will be visible. This will be visible. This is dotted. This is dotted. This is dotted. This is dotted. And this is dotted. You have completed the vertical prism, hexagonal prism standing on its base on the ground. Now, where is the axis? I have not marked the axis. How will you mark the axis? You know the diagonal of the rectangle or the diagonal of the hexagon will pass through the center. I repeat, the diagonal of the rectangle or the diagonal of the hexagon will pass through the center. Therefore, it must be same here. You can draw the diagonal of the rectangle. Rectangle here is a parallelogram. So diagonal of the parallelogram or diagonal of this hexagon will meet at the center. I draw very lightly 2 lines. O, P. What is OP? OP is the axis. OP is the axis. Agreed? Now, suppose it is a hexagonal pyramid. Suppose it is a hexagonal pyramid. What you would have done? You would have drawn 1, 2, 3, 4. You would have found out the axis. You would have found out A, B, C, D, E, F. Then locate O, take the height of the pyramid up, locate P, and from P draw slant edges to the corners of the base. That's a pentagonal, that's a hexagonal pyramid. Agreed? I repeat. Draw 1, 2, 3, 4. Draw all the 6 points of the hexagon plus 1 point of the hexagon. Take the height up to get P. From P, draw slant edges to represent the original slant edges of the pyramid. Agreed? That is how you draw a hexagonal pyramid. Now, if it is in this case, you can also do one thing. Instead of drawing 1, 2, 3, 4, 5, 6, 7, 8, you can draw 1, 2, 3, 4. Take the 6 plus 1, 7 points. Then from these 7 points, take the height up and get the corresponding top points. It's not necessary that you include it in a box. You can draw 1, 2, 3, 4, get 6 plus 1, 7 points. Then from all the 7 points, take the vertical height 60 mm up and complete the top points. That also you can do. But inscribing it in a box will have a different kind of compact appearance. But you have to be careful, the box, the blue lines, the box must be very light because such a box doesn't exist. Okay, when it comes to a pentagonal prism, you do exactly the same thing. Draw a pentagon, inscribe it in a box, draw the isoview of the box, inscribe the pentagonal prism inside the box. Agreed? Inscribe the pentagonal prism inside the box. Now, how do you get the center of a pentagon? If this is a pentagon, how do you find the center of the pentagon to get the axis? What is the procedure? The easiest way is, I have already told in some other video, join a corner to the center of the opposite side by a line. Join any other corner to the center of the opposite. Join any other corner to the center of its opposite side by a line. They meet at the center. The same thing you have to draw or do in the isoview. Agreed? You have to do the same thing. But the problem there is, say you can see, this is 25 mm, 25, 25, 25, 25, 25, 25. Correct? This will be 25 because it is along an axis. This will be 25 because it is along an axis. This is not 25, this is not 25, this is not 25, this is not 25. So you have to find whatever is the side, whatever is the length represented there, find its center and join it to the opposite corner when you find the center of a pentagonal prism. Center of a pentagon. If the pentagon is 25 mm side, when you draw its isoview, all sides will not be 25. Only one side will be 25 because this will lie along an axis. No other side will lie along an axis. Therefore, no other side will be true length. So you have to find the corresponding center to join it to the opposite corner to find the axis of the prism. So that is how you draw a pentagonal prism. When you draw a pentagonal pyramid, same thing. Don't get all the points on the top, only get the apex and join them to the corners of the face. That is how you draw a what you call a pentagonal prism and a pentagonal pyramid. Similarly, you can draw square prism, square pyramid, triangular prism, triangular pyramid, and things like that. The one more problem which I draw in this video is a cylinder. It's a cylinder. Very simple. If you assume a cylinder 50 mm diameter and say 60 mm tall, a cylinder 50 mm diameter, 60 mm tall, standing on its base. How will you draw that? We have already learned the four-centered method of drawing circles, isomeo circles. Cylinder has two circular faces, correct? So what you do is, draw a rhombus. If the cylinder is 50 mm diameter, draw a rhombus, 50 mm side, 30, 30. Take the height up from all the four corners. See, since it's a rhombus, a vertical line through, this will pass through this. Check. What is this? It's a square box inside which the hexagon, the cylinder is kept. Now, join the northern diagonal, find the centers of the sides, join them to the obtuse angles. Do the same thing in the plan, in the bottom. Now what? Use four-centered method and draw an ellipse. Use four-centered method and draw an ellipse. Draw two tangents on the sides. My bottom ellipse looks a little bit bigger. I didn't take sufficient care, became a little bit big. Okay, I'm managing. It's a cylinder. Almost half of the bottom ellipse will be dotted. When it comes to a cone, what will you do? Draw this rhombus. Get the ellipse, take the center, take the height, and from the height draw tangents to the side. Don't draw firm lines. Fix a cone. Draw tangents to the side. Don't draw it to this, join it to these two corners, these points. Because if you do that, say suppose this is the cone, this is the base of the cone, and the height of the cone is less, only this much is the height. If you join the apex to these corners, these points, what will happen? You will get a small part of the ellipse going outside. Agreed? That's not possible. So what you have to do? You have to draw tangents. You have to draw tangents to the ellipse. I hope you understand. So what you have learned? We have learned how to draw isometric views of small block. Then a pentagonal, hexagonal prism, a hexagonal pyramid, a pentagonal prism, a pentagonal pyramid, a cylinder and a cone. All standing on base on the ground. Agreed? With this basic knowledge, we will go to isometric views of solids, combined solids, which used to come for university examinations in all universities. We will go to problems of that level. I hope you understand. Isometric projection is comparatively easy. You can use your set squares to draw this. With your set squares, you can draw very fast. You have got a set square 30, 60 now. This is 30, this is 30. So you can simply keep your set squares in two positions and draw them fast. Okay then? Thank you.